Q8098. During discharge, nickel-cadmium batteries will show a lower liquid level than when at full charge because A. A chemical action causes the electrolyte to evaporate through the vents. B. Current leakage from individual cells causes a rise in temperature. C. The electrolyte becomes absorbed into the plates. The correct answer is C. During discharge, the electrolyte in nickel-cadmium batteries is absorbed into the plates, which causes the liquid level to decrease. This is because the chemical reaction that occurs during discharge causes the active materials in the battery to change, resulting in the absorption of the electrolyte into the plates. However, during charging, the liquid level will rise again as the electrolyte is forced back into the cells through the process of electrolysis. Q8090. Which of the following statements is divided by are generally true regarding the charging of several aircraft batteries together? 1. Batteries of different voltages, but similar capacities, can be connected in series with each other across the charger and charged using the constant current method. 2. Batteries of different ampere-hour capacity and same voltage can be connected in parallel with each other across the charger and charged using the constant voltage method. 3. Batteries of the same voltage and same ampere-hour capacity must be connected in series with each other across the charger and charged using the constant current method. A3. B. Current leakage from individual cells causes a rise in temperature. C1 and 2. The correct answer is C. A series connection can be made between batteries with differing voltages but equivalent capacities to use the constant current method to charge them. If batteries are charged using the constant voltage approach, they can be connected in parallel and charged at the same time, even though they have different ampere-hour capacities. Q8099. How can the state of charge of a nickel-cadmium battery be determined? A. By measuring the specific gravity of the electrolyte. B. By a measured discharge. C. By the level of the electrolyte. The correct answer is B. The state of charge of a nickel-cadmium battery can be determined by a measured discharge. This involves discharging the battery at a known rate and measuring the time it takes for the battery voltage to drop to a predetermined level. By comparing this time to a discharge curve, the state of charge can be determined. Q8100. What may result if water is added to a nickel-cadmium battery when it is not fully charged? A. Excessive electrolyte dilution. B. Excessive spewing is likely to occur during the charging cycle. C. No adverse effects since water may be added anytime. The correct answer is B. As a nickel-cadmium cell is discharged and charged, the electrolyte concentration varies. The level is at its lowest during cell discharge and at its maximum while charging. When a cell is fully charged, if water is introduced before some of the electrolyte has been absorbed into the plates, the level will be too high. When the set is nearly finished with its charge cycle, some of this extra liquid will probably erupt out of the device. Q8101. In nickel-cadmium batteries, a rise in cell temperature? A. Causes an increase in internal resistance. B. Causes a decrease in internal resistance. C. Increases cell voltage. The correct answer is B. A nickel-cadmium battery's low internal resistance, which enables it to absorb and discharge power at rapid rates, is one of its most appealing qualities. A nickel-cadmium cell's internal resistance and voltage change in direct proportion to temperature. Voltage and internal resistance both decrease as cell temperature rises. As a result, the battery is able to accept an excessively high charging current, which generates additional heat and may result in a thermal runaway.